Now we want to try and understand this diffraction pattern here, where we have light going through a narrow but tall slit. This image here is just a top-down view of that narrow slit of width A. And we consider two rays, one coming from the top edge, top in this viewpoint, and one coming from the middle, a distance a/2 away. Now, because you have to travel a little bit further distance here along ray 2, these two rays could be out of phase. If the distance along the central axis, D, is much greater than the slit width A, then these two rays are nearly parallel, as illustrated here in part B of that same picture. That means the extra distance is just this little blue segment here. Well, this angle theta is the angle from the center to our point of interest, and it's also the angle here between the line between the two rays and the perpendicular line between them. That means that this extra distance here is simply a/2 times the sine of theta. Now, if that a/2 times the sine of theta happens to equal lambda/2, then each of these rays will cancel each other out. These two rays will cancel. And you may say, well, that's fine and dandy, but there's lots of other rays in this situation. That's true, but I can take every single ray across this slit and put it into a pair just like these two. In other words, I can consider a ray slightly further down, but it's going to have a pair that is a distance a/2 further down. And one further down still will have another pair, a distance a/2 further down. So every point along this slit can be paired with another point that is half the slit width away. And at this exact same angle, where a/2 sine theta equals lambda/2, each of those pairings will cancel out. I'm going to make a slight change here and change the color of these pairings. That should make it a little easier to see which rays are canceling out. Well, I can come back to this equation, and it's clear that the 2's will cancel. And that tells me that when a sine theta equals lambda, then I will have a minimum, a dark point, in my pattern. And that means everywhere from this first angle, a sine theta equals lambda, to the angle on the other side, where a sine theta equals lambda, that entire range will have a bright spot. That will be this central wide bright spot that we saw here.